Alright, so we are continuing on in 9.8. We're going to be looking at DeMoivre's theorem for powers and roots of a complex number. So, when it has powers, just to say, hey, like simplify this complex number. We see it's complex, so there's an I in it, but now we have this parenthesis 3 along with it. So, whenever the 3 is, you're going to kind of want to use the two formulas, so I'm going to write them off on the side. So, DeMoivre's theorem says that z to the n, so if you have some complex number raised to the n, that is r to the n times cosine of n theta plus I sine n theta. You could also write it as just cis n theta. Alright. I'm going to use this just to keep it a little bit simple. Well, we'll see. We'll see how it goes. Alright, but that is a formula. You begin this on the formula sheet, so you're good to go from there. So, as you can tell, the big thing is the formula is only in polar, and specifically polar complex. But our problem, this is in rectangular complex. So I need to convert. So I'm going to go ahead and draw this. That's negative 3 root 3 in the real direction and then negative 3 in the imaginary. So it's somewhere down here in what would be Q3. So if I filled it in, that'd be 3 root 3, negative 3. So for polar, I need R and I need theta. So my R, well, I could use Pythagorean theorem. I could also see that I have kind of a pattern here. 3 root 3, that means that this is going to be 3 root 2, which is 6. Like I said, you could use Pythagorean theorem if you wanted to. That would be negative 3 squared plus R squared, that's 9 plus, this would be 9 times 3. So 9 plus, 9 times 3 is 27. 36 is R squared, and take the square root together. Okay, so now you got that. So now you do see that this is a pattern. So it is a 30, 60, 90 triangle. So it has a 30-degree reference angle, because that's the smallest one. So my theta is going to be 210. Right. Now, since it was in rectangular complex, it didn't tell you to use degrees or radians. So you can choose either one. I'm going to show both right now. 210 as radians would be 7 pi over 6. Okay. Remember, all these problems are non-calculator. So it's actually going to depend on the situation. One of them's going to be better than the other. I'm going to show both of them here, though, for us. Okay? So, I can now write Z as that polar complex now. So Z is 6 times cosine of theta, which is going to be 210, plus I sine of 210. And that is raised to the third power, because that's what it was given in. Raised to the third. Alright. So, what this tells us is the formula says, hey, if I have something raised to the n, if I have a complex number raised to a power, I'm going to multiply, I'm going to raise the radius by it, I'm going to multiply the angle by it. Alright. So, if I did that here, that means that this becomes 6 to the third times cosine of 210 times 3 plus I sine of 210 times 3. Right. The problem is now, without a calculator, this could get pretty big and you might make a mistake. So you might not want to do it in degrees. Radians might actually be better here for us. So I'm just going to rewrite it in radians for us. Remember, 210 is just 7 pi over 6. I'm just going to replace it. Alright. So here I could see it. So I'm dealing with fractions. It's actually going to be a little bit easier to deal with multiplication. So again, this is in just degree. and that's just in radian. That's the only difference between these two. Either one is fine. I'm going to actually keep in radians because I think it's going to be a little bit easier with this. So then 7 pi over 6 times 3, that 3 is over 1. It's going to cancel out there. It's going to be 7 pi over 2 plus I sine of 7 pi over 2. Notice those angles are the same, and they should be the same. So we could have written this in our cis form if you wanted to. All right, all the same thing. These are the same. Okay. So if I wanted my final answer, it would be here. This is in polar complex. Let's say I wanted to go back and actually get it into rectangular complex, kind of simplifying the original thing in rectangular complex. I could just evaluate like we always do to take to go from polar complex to rectangular complex. We just evaluate. So I'm going to take this and just evaluate. So 7 pi over 2. So pi over 2, pi, 3 pi over 2, 2 pi, 5, 6, 7 pi over 2 is actually here. Okay. And so that has a point like 0, -1. So when I do this, right, cosine of that actually just becomes 0 plus I times -1. I could do 6 to the third. I could multiply that out. That's 36. 6 times 6 is 36. Times 6 is 216. So this really is just -269. So just as a recap, depending on what the directions say or how far you have to go, we are taking a rectangular complex number with a power of 3. Okay. My formula only allows me to use the formula in polar, so I had to get it in polar. Again, you can either do that in degrees or radians. Either one works. Since I don't have a calculator, this can get kind of messy, so I'm going to choose to actually do it in radians. And this would be my final answer if it was just to rewrite it in polar. All right, to apply that formula and get into polar. If you wanted to simplify all the way, you could get it back into rectangular, which is here. So this is equal to that original question. But this is just, it's simplified down. Or you could do it, like I said, in this formula. This one is just polar. But either one works. All right.